So good morning to all of you. I welcome you to this session of Big Data Analytics Lab. In today's session, we'll be discussing about the following topics. Uh, I'll be discussing how we can set up trash in HDFS, then how you can configure the WebUI of Hadoop, the web user interface of Hadoop, how the block size and replication factor can be set up, and what it means to a cluster. Then what are the checksum.meta files and how we can locate them in our system and working with HDFS commands. Okay, so let's understand first of all what is this trash setting in HDFS. So let's go to terminal. Okay, and let's see whether our distributed file system services are running. So a cluster is ready for use, right? So what I'll do here is I will display a few files for you using the Hadoop fs ls command. I'll display the files from the root of the distributed file system. So you can see the files are there. Now I'll delete one of these files. I'll delete P99. Okay, this is a directory. Sorry, I'll delete this file, say checksum. I'll delete the checksum file from the cluster. I can do it using the rm command. Okay, Hadoop fs -rm, and then I can do this checksum like this. Okay, so usually what happens in your Windows or in your Linux environments, that if you delete something, it goes to trash. Okay, like in Ubuntu it is trash, in Windows it is recycle bin. So it goes there so that if required, you can recover those files which have been deleted accidentally or which are required after deletion. Okay, let's see the current status of our cluster. Okay, if I remove the file, what it says. Okay, the message is that it has deleted the file. Okay, that means our trash is not set up. Otherwise it would have given a message that the file checksum has been moved to a folder named as .trash. Okay, so we need to configure our configuration files so that we can set up trash properly, so that whenever something is removed from your cluster, it goes to trash, and if required it can be recovered from there. Okay, so let's have a look at our trash settings, like how we can set up the trash. For you to set up trash, you require a few properties. They are on screen now. Okay, now in coresite.xml file, you need to set up a property fs.trash.interval. That means the duration for which the file would stay in the trash. It can be set up to any value. I have set it up as 3 minutes. Okay, and then fs.trash.checkpoint.interval. Okay, this I have set up as 1 minute. It means after every 1 minute, your trash would be checked and files which are longer than 3 minutes would be removed. Okay, then to configure your WebUI, there are a few settings. I'll discuss them here itself. There is a property in coresite.xml, that is hadoop.http.staticuser.user. You set it up to your username in which you have set up Hadoop. In our case, it is HD user. And there is a property in hdfs site.xml which gives you permissions to delete from your WebUI. Okay, you just set it to true. The property name is dfs.permissions.enabled. So why this is required? Let's understand this thing. Let me try to delete something from here. Okay, let's first refresh so that you can see checksum file is gone. Let me remove this file checksum.odt by clicking on this delete button. If I click and if I try to delete, it says permission denied. So to take this permission, you require this property in hdfs site.xml and this property in your coresite.xml. If these two properties are set, you can delete from your WebUI. Otherwise, you'll get a message similar to this, that permission is denied. Okay, so now let's set up these properties. So I'll copy the entire content from here for the coresite file. Okay, I'll copy it and then I will open up the coresite file here. You know where your coresite or all XML files are located. Okay, so I'll go to that path in my default installation folder. Yeah, I think here we should have Hadoop, then etc, then again Hadoop, and then the file course site.xml. You open this file, just add those properties here. Okay, so I will add them here. Okay, I've added the properties here, and then I will save and come out. Okay, fine. This is one setting. Then in your HDFS site file, one property needs to be set there. Okay, I'll pick it up from there and copy it here. This is the property setting here. Okay, let's copy it and let's paste it here. Then save it and come out. Now you stop your distributed file system services so that whatever changes you have made in the core site.xml can be taken up, right? There is some problem. Yeah, we missed something. Let's open up core site. Let's see what we have missed here. Yeah, we missed the closing property tag, I suppose. Should be fine now. Oh. We have to start the services. Let's start the services now. Let's locate where our start is. So let's start the services again. Let's hope that all is fine now. We'll first check the delete button. Yeah, all is fine, I suppose. Let's refresh our cluster here. Okay, and let's try to delete this file now. So right now the name node is in safe mode. So that means the deletion is going to work fine, right? Let's now also discuss about the replication factor. Okay, so you can see here in HDFS site, we have set the replication factor as 1 using this property dfs.replication, and I've set the block size as 2 MB. Okay, I've set the block size as 2 MB. Also in this file, I have specified my name node and data node directories. So remember, these directories are in the path user local Hadoop underscore store HDFS. So below HDFS directory, both these name node and data node directories are there, and they contain important information as I'll discuss in this session, right? So let's now go to WebUI and see whether the safe mode is over or not, and whether the delete button is configured. So you can see now it's okay. Now the delete is configured. But what about the trash that we set up? Now let's remove another file from our distributed file system. I'll first list the files for all of you so that we can see how it works. I'll remove the file, say Hadoop, the star.gz file, right? I'm going to remove it using the rm command. I'll write like this, and then I'll specify a slash here. I'm removing this file. Now see the message. Okay, now it's not deleted message. Now it's a message is that the file has been moved to this folder. Okay, so at this name node, okay, this file has been moved to trash, and this is the path where it has gone. It has created a user folder automatically. Once you configure the trash and remove a file from your terminal for the very first time, your trash is configured, and now you can see an additional user folder. Right now it's not there. Once you refresh it, you will see a user folder below which there is a HD user folder, below which there is a trash folder, below which there is a current folder, and below which is your file that you just removed. Now this current folder stays for till the clock ticks to the next minute, and after that it will change to a date time folder. So it will change to a date time folder at 11:25 a.m. Now it will change to a date time folder. Okay, and 3 minutes after this, that is at 11:28, this file would be removed from the trash, which is there in the trash right now. So if you require it, you can move it back from this place to some destination that you like. Okay, now the trash is configured. Okay, this is how you can configure trash, and you can understand the properties that when you set that fs.trash.interval property as 3, that means once you get a date time folder, okay, once you get a date time folder like this, I'll just start this, okay. Yes, okay. So this date time folder, once it is created, the moment this timestamp shows 11:25, 3 minutes after that, it would be removed from the trash. The file would be removed from the trash. But there is a delete button in WebUI, like whatever you delete from your WebUI, okay, that does not go to trash. Remember this thing. Only from the terminal using the RM command when you remove, it goes to the trash. Otherwise, from your WebUI, whatever you delete does not reach trash. And the file retains its path in the trash. Okay. What I'll do is I'll just remove this folder from here so that our trash is empty. I want to show you something. And let's reach our root here. Okay. And let's go to this temp directory. Can you see? Okay. There's a temp directory, but let's go inside it. It is having no files right now. Okay. Then let's create a folder and put a file in that so that I can just specify my point to you. Hadoop fs-mkdir, okay, and say I want to create a folder Ajay below the root. This will create the folder, right? Let me copy a file to this folder. So I'll just put a file, transfer a file, this file to the Ajay folder. Fine. So if you locate in your WebUI here, you will see a Ajay folder below which there is a file examples.desktop. So if I remove this file from this place, from the Ajay folder, okay, let me remove this file for you. I will remove this file examples.desktop, right, from below the Ajay folder. Yeah, I wrote user, I'll write Ajay here, right? So I'm removing this file, okay, examples.desktop. You can confirm this by, clicking on this path. There is no file here now under the Ajay folder because it has gone to trash. But how it looks in trash, kindly have a look here. It will retain its original path in trash. That is in trash. Below the datetime folder, there would be a Ajay folder, and below that there would be the examples.desktop file. You can have a look yourself. So trash, there is a datetime folder, then there is a Ajay folder, then there is examples.desktop file. So whatever path you remove the file from, the same path it retains under the datetime folder in the trash. Okay. I think setting of trash is clear to all of you. Next, the configuring part is also done. How you can configure the delete button so that it is always accepting, and whatever you delete from your WebUI of your cluster does not go to trash, remember. Okay. So be careful while you are moving files from the WebUI of Hadoop. Now, block size and replication factor we have already seen. Now, what does it mean to a cluster? Okay, let's discuss that now because that would be important. Let's look for this file only. In the root, there is a file. Let me just remove this folder from here, and let me just clear the trash so that we are clear about certain things. Let me clear this thing from here. Right, this is done. Let's now come back to root. Note carefully this thing now, which I'm going to discuss. There is a file examples.desktop. If you see its size, it is 8.77 KB, right? It is 8.77 KB, and the block size is 2 MB. So you divide the size of the file with the block size to get the number of blocks. So obviously 8.77 is much less than 2 MB. So the minimum one block is required for this file. Okay, you can see it here. If you click on this file, you will see that there is only one block of size 8980 bytes, right? Now I'm going to discuss next with you what is the checksum for this file. So I'll be discussing the checksum of this file. We have just seen the block size and how it is calculated. The total size of the file divided by the block size of the cluster, you get the how many blocks would be there for a specific file, right? And then there would be a checksum.meta file. Okay, how we can calculate that file, right? Let's see that. For that, let me just open up a calculator for you. You already know the concepts of calculating the .meta file. I'll show it to you here. So for your this file checksum.meta file, there is something known as a header, which is of 7 bytes. Okay, and remaining whatever is the block size, like it's 8980, I suppose. 8980, right? 8980 divided by 512, because some bytes are added for every additional 512 bytes in your file. So you divide the block size with the 512, whatever value you get. Okay, you take an integer value out of it on the higher side. Even if it is 17.11, you take it as 18. Okay, so take it as 18 like this. And we discussed for every 512 bytes, we have 4 bytes of checksum. So 18 into 4 is 72, plus the checksum, that is 79. So if we go for the header, sorry, the header is 7 bytes. So the total is 79 bytes for this checksum.meta file. Now, how to verify this? How to locate this? That is the next thing. How to locate our checksum.meta files. Okay. For that, you go to files, then you go to computer and to your default destination folder, that is user, then local, and within that you need to go to your data node and name node folder. So go to Hadoop store, then go to HDFS, then go to data node. Okay, I hope you are noting it down. Then go to data node, then current, then the block pool folder, then the current folder. Go to the current folder, then go to the finalized folder, then go to the subdirectory and locate for your file. Okay, let's see which block we are looking for, because there would be hundreds and thousands of block. So let's locate the block ID for this. It is ending with 2856. You can see here it is ending with 2856. So let me locate for that block. It's not here. So let's locate in subdirectory for it is this block, right? Examples.desktop file. You can see the block. The block number begins with BLK underscore prefix. This is the block. If you locate its size, it would be 8980 bytes. You can see here. Okay, 8980 bytes. And if you see its .meta file, the nomenclature is first the block number, then underscore some number and .meta. This is the checksum file whose size I'm saying should be 79 bytes. So you can check the size here. It is 79 bytes. So if this is like this, that means everything is okay with this block of file. Okay, and you can locate it here in your data node folder. Then also one more thing, there are 2 folders in your data node current block pool folder. One is a finalize, where all the blocks which are finalized, which are okay, they are transferred there. And while they are being finalized, we have a folder with the name as replica being written. Okay, and first the block and its meta file comes here, and after after they are confirmed that they are okay, then they move to the finalized block. I would like you to see this process here. Okay, I will copy a big file. Okay, I'll use Hadoop fs-put and I will transfer this file. Okay, this is a big file here, right? And I will transfer it to the root. I'm transferring this file, which is of approximately 600 plus MB. So divided by 2 MB block size, so 300 plus blocks would be there. Okay, and what I'm suggesting is all the blocks would first come in this folder, each block and its .meta file, and immediately after confirmation it will move to the finalized blocks under the various subdirectories would be created for them. So maybe I can just remove some subdirectories, but then it's okay. You can have a look here. We just focus on screen, right? This is the replica being written block. So once the process starts here, the blocks will start coming here. So I've just started the process here. Okay, and I'm going here now, and I'm showing you the RBW folder. Okay, you can see the block and its meta files appearing. Okay, let's go to the finalize to see what is happening there. Okay, let's go to this subdirectory 6. You can see the block and its .meta files coming here. Okay, so all the process is transparent to you. Okay, there's no problem here in this distributed file system service, right? And once you have the thing finalized here, you will see the file appear here. Till that time, okay, let's just close this. Let's slow it down. It is just slowing down a bit. Let's see, go to a terminal. Yeah, now it's fine. So if we just update this, the process, the file is being copied. Just update it now. Yeah, it is still copying. You can see the copying still going on. Okay, because the blocks and meta files need some times, some confirmation time before you are sure. Let's update it. Still showing the copying status here. And once copied, you will see the size of this file so far is 526 MB, right? It is still copying the block. So once you update it, now it has been copied. You can see the size is 577.15 MB divided by 2 MB block. Okay, so it should be some 300 plus blocks. You can see it here by clicking on this file and looking at the blocks. Okay, look at the blocks. All the blocks are here. So let's see how many blocks are there. Okay, yeah, 570 something. So 288 blocks, 289 blocks are there, numbered from 0 to 289. All the blocks are of size 2 MB. You can see here. The last block would be either 2 MB or less. Let's see what's the last block. Yeah, it is this. It is lesser than 2 MB. You can see the last block, right? So I hope this process is clear, how the blocks, the meta files are created, what is their size, where they are located. You've seen the process, how they are actually appearing there, right? So now next, another thing that I think I should be discussing with you is about the startup progress of our cluster. Okay, so whenever our cluster starts, there are two files, as we discussed in our theory sessions, that there is a permanent file of your cluster known as fs image, and there is a edits file. So the moment you start your cluster, and if you keep on working, all the edits files, they record the changes which are made to your cluster. And after a fixed interval of time, these edits file is merged with the fs image file to get an updated fs image file. Okay, I'll show you where all these are located. So for that, we will go to our name node folder, right? We'll go to the name node folder. So let's go to our name node folder here. This is the name node folder. Within this, you go to the current folder, and within the current folder, you will have the other files, right? It's just loading, just taking up some time. Yeah, you can see all these files. So ever since I've been working on this cluster, all the changes have been recorded in various edits files, one for each session that you carry on. And there would be a edits in progress file. Like for the current session that we are doing, there would be a edits in progress file. I'll show it to you. Here is this file for our current session. Let's locate it. Yeah, it's there. Can you see? Edits in progress. This file is taking up today's changes. Like I've been deleting file, copying files, doing all sorts of things. Okay. And then there are your fs image files. This would be the fs image file, and along with it, there is a checksum file for this with an extension .md5. Okay. So all these files are located here. All this process is transparent for you, right? So next I'll be discussing some HDFS commands with you. Okay. Already we have discussed, so it would be a good revision for all of you. We'll be discussing the HDFS commands. So let's now discuss some of the HDFS commands. For that, I'll go to the terminal. Okay, the very first command that we would write is the list command, right? So you see the similarity between the Linux and the HDFS commands. Most of the commands are similar, some are different also, but the one big difference is that an HDFS command begins with a hyphen. Okay, and then the command, and then the parameters and all the paths, right? So if I write this listing command here, it will list all the files in the root of my distributed file system. Okay, then I can change the path, like I can just write it without any path. Okay, so when I don't mention any path in my HDFS command, it picks up the default path, that is my user HD user folder. So now this list command would show me all the files or directories which are present under the user HD user folder. Remember this thing. Okay, so you will see that this is the only, there is one folder below user HD user. You can confirm it from here. Go to your user folder, to your HD user folder, you see a trash folder there. So we have displayed this by not mentioning any path. We could have mentioned an explicit path like this also, like Hadoop fs-ls. I could have gone with the HDFS scheme like this, like HDFS localhost, then the link to my name node. If I write like this, it will give you the same output, but more explicitly it will tell you where this trash folder is located below the root. Okay, this is the path here. Okay, now to mention your local file system in your HDFS, the scheme name is file. Okay, so just have a look here. I will change this to this file, then home HD user. Okay, when I write like this, that means I want to list the files from my home directory. Okay, so it will list all the files present in your home directory, right? It will display all the files present in your home directory. And you see, I have not used a long listing, but the when you mention a scheme name, the long listing automatically comes. Then I can display the files in the root of my local file system. For that, I need to write file colon 3/. Now it will display all the files which are present in your local file system, the root. This is the files in the root of your local file system. You can go to root. Now this is the root. If you list the files, you will see similar files here in this listing. Okay, you can see the files are the same. There is an app folder, there is a bin folder, there is a boot folder. So this command that you just used here will list all the files from the root of your local file system. And this command that you see on screen, this would list all the files from your default path in HDFS, which is the folder user HD user. Okay, this is regarding the list command. Then I will discuss a few commands which we have used for copying of files, moving of files within the distributed file system, and from between local file system and distributed file system. So I'll work fast with them. I'll take up one file. For example, let me create that file. Say I'll use the cat command to create the file. Okay, I'm in root, so there is no permission. So let me just go to my home folder and I can create a file like this. That's it. Okay, P111. Let me transfer this file to the distributed file system without using the put command. Okay, so what alternative do I have? I can use this command, copy from local. Okay, Hadoop fs-copy from local, then the file name. Okay, and then the destination. I'll transfer this file from my local file system to the distributed file system root. Okay, so I've copied it. You can go here. Right now, you see, if you update it, you will see the P11 file appearing on in your this. This is the P11 file. You can see it here. Okay, so next I'll do the reverse command, copy to local. So you can see copy from local is similar to your put command. Okay, and then what I'll do is I'll remove this file from my local file system. Now it is not present here. You can see there is no such file. Okay, so now I'll do the reverse. I'll use a copy to local. Now this command means that copy the file from your distributed file system to your local file system. So I'm saying here, copy the file P11 from the root of the distributed file system and copy it to the local file system. So this command is similar to your get command. Once you do it and once you list the file, you can see that this file has now appeared in your local file system. Then I will talk of CP and MV commands. These commands are for your only specific to your distributed file system paths. When you use CP and MV as an HDFS command, it is only for the distributed file system paths. When you use CP and MV for your local file system, it is only for your local file system, right? Okay, so let's work with this by having a look at our cluster. You can see a file M90 here in the root. All of you can see M90 here. I will move it to the user folder. Right now user folder is not having any file, only HD user folder is there. So I'll copy M90 from the root into the user folder. Okay, I'll copy it. I'll use a command here, Hadoop fs hyphen copy. So when I use a copy command as an HDFS command, it takes HDFS as the argument, HDFS paths as the argument. So M90, this is the first path from root to be transferred to the user folder. Okay. So if you see the effect here, copy means the file is here also, the file will stay here also, and it would be there in the user folder also. You can see it has been copied here. Okay. Then what I'll do here is, kindly keep a close look at what I'm doing. I will delete the file from here. See, I've removed the M90 file from the root. It is still there here, M19 user. So I'll move it from here to root so that it does not stay here and goes to the root. Okay, let's do that. Now we have a move command here. The file name is below the user M90 and the path where it goes is the root. I hope you understand this command. It says move the file which is present in user folder, file name is M90, to the root, so that it does not stay any longer in user folder but stays now in the root. So I have started this command here. So right now it's there. Once you refresh it, it's gone, it is moved, and if you go to root, you will see the M90 file here. Okay, so remember, CP and MV are the commands which are specific to your HDFS paths only. Okay, so I think that's all for today's lab session, and I'll come up with the more HDFS commands and Apache Pig commands in my future lab sessions with you. Thank you very much.